Hello there. This time I'm back again with a topic from physics. It's called friction. So, what is friction? The force that opposes motion is called friction. For example, when you stop pedaling your bicycle, it comes to rest after a few seconds. This force exerted by the road on the bicycle tires which stops it is called friction. This frictional force always acts opposite to the direction of motion. So in the example of bicycle, the frictional force is acting backwards, so the bicycle comes to stop after a few seconds. Now, factors affecting friction. One of the two factors that affect friction is nature of the two surfaces. Now I'll explain and demonstrate this with the help of an experiment. Now here's a slope that I have, and I have a small object like a pencil cell which I'm going to roll from this slope onto the floor of the terrace. Now when the object here, a pencil cell, is released, as you can see, it goes ahead probably a meter. Now what I'm doing is I'm replacing the foam terrace with a towel. There's a towel that I'm spreading, and now again I will roll the same pencil cell, and this time, as you can see, it hardly traveled 12 to 13 centimeters away. So what was the difference? It was the nature of the surface that made all the difference. Initially, the surface was firm and hard, that is the floor of the terrace in this case, and when I replaced it with a rough surface like this terry towel over here, I don't know if you can see it if I take it closer. So this was much rough a surface, so the friction provided by this surface was more, and so it was not able to travel a larger distance than in the earlier case. The second factor is the force with which the two surfaces are pressed against each other. These two I'll demonstrate with an example or an experiment. The bottom of the tray and the floor look very smooth, but it is not actually so. Now I have a big heavy pile of books on this tray. I try to push this tray. It's very difficult to push, though I am able to do it with much force, as you can see over here. Now I'm removing all the books. Now, even with very little force, I'm able to move the tray. So, I hope you get the difference now in both the cases. Even the floor and the tray, like I just said, that appear smooth, has innumerable irregularities on them. So, when this tray is pushed on the floor, then the irregularities on the tray and the floor interlock and produce friction. Now when the tray is empty, what happens is its weight is less, and so it presses onto the floor with less force, and so the friction is less, and so I am able to push the tray easily, which was not there in the earlier case because it was quite hard to push the tray because of the load on the tray. Types of friction. There are basically two types of friction: dry friction, which is between solid parts, and fluid friction, which is the friction exerted due to fluids. Now in dry friction, there are three types. The first is static friction. The frictional force that keeps an object at rest and does not allow it to move is called static friction. This frictional force must be overcome by applying more force to start moving the object. The simple example was the tray that was loaded with books. I had to overcome that frictional force in order to move that load of books on the tray. The second one is sliding friction. The frictional force that resists the motion of the two objects when they slide over each other is called sliding friction. The demonstration can be the same like when I pushed the tray loaded with books. It was sliding over the floor of the terrace. And the third one is rolling friction. The frictional force that resists the motion when one body rolls over the surface is called rolling friction. This I'll demonstrate with an example. Here I have a bag which is very heavy. I need to apply a lot of force in order to move the bag because it is loaded. A lot of force has to be applied. On the other hand, now this is the trick behind it, the rolling friction. Here I have rollers at the bottom. I hope you can see them. Now, a very little force is required in order to move the same heavy bag because of the rollers. So these rollers reduce the friction and thereby makes the movement of this heavy bag easier with little force. Now let's understand fluid friction. First, we'll have to understand what are fluids. Fluids are those substances which can flow easily and have no fixed shape of their own. Examples are liquids and gases. So the frictional force that resists the motion of an object when it moves through a liquid, that is maybe water, or a gas, that is maybe air, is called fluid friction. Then we come to viscosity. Viscosity is the fluid's resistance to flow, and also the drag. The frictional force exerted by fluids in general is called drag. Now, drag exerted by a fluid depends on three factors. The first one is the nature of the fluid, that is the viscosity that I just talked about. Now, suppose you have an object A that is moved 100 meters through air and it reaches to place B. Object is at A, it reaches to place B. And the same object A is in water, it also moves through the same distance. Let's say it is 100 meters in air and 100 meters in water, and it moves through the same distance and reaches the place B. Now, what you see over here is more the viscosity of the fluid. Now, mind you, water has more viscosity than air. So, more the viscosity of the fluid, greater the frictional force on the object that moves through it. So, water will exert more frictional force than air because water is more viscous than air. Similarly, sugar syrup has more viscosity than water. Next is the speed of the object. Higher the speed, greater the frictional force acting on it, that is, greater will be the drag. Here I have given the example of the same car. First, when it is moving at 180 kilometers per hour, and the same car then moving at 80 kilometers per hour. So when it is moving at a higher speed, 180, it experiences more drag, and then when it is moving at 80 kilometers, where it experiences less drag. And the final is the shape of the object. In nature, most of the objects, that is fishes, to give you an example, or birds. Fishes travel in water, birds travel through air. They are designed in such a way that they offer minimum drag. And this process of designing to offer minimum drag is known as streamlining. So the same principle is also used when designing aircrafts. They are streamlined so that they offer minimum drag while traveling through air. And even high-speed trains like the bullet trains, they also offer minimum drag so that they are designed in such a way that their body becomes streamlined. And that is the reason that if you have a car which is streamlined design, the wind cuts through the shape of the car, offering less drag than in the case of a bus where there is a lot of surface area. I mean, the bus is not streamlined. It's not designed in such a way, so it offers more drag and then the same car which is streamlined and designed accordingly. Friction is a necessary evil. It has its own merits and demerits. First, let us look at the merits. We can walk on the ground because of friction. We can light a matchstick because of the friction between the matchstick and the side of the matchbox. We can slow down or stop a moving vehicle when we apply brakes, which is due to friction. We can ride on paper or smartboard, of course, thanks to friction. Friction also helps to drive belts in machines in factories. If there were no friction, then the belts would keep on rolling round and round and would not give any movement. We can also ride a vehicle because of the friction between the tires and the road. If there was no friction, then the tires would keep on spinning at the same place and the vehicle would not move at all. And very important, nature has given us fingerprints on the fingers and palm in order to increase the friction and provide a better grip. The demerits are, friction brings about the wearing of soles of footwear and vehicle tires. Friction also generates heat that gradually damages machine parts. Now, to give you an example is when we use a mixer, we operate a mixture, so the machine becomes hot. That is due to the friction that is applied when the mixer moves fast. Also, the moving parts of machines in factories generate heat due to friction. Now, what happens is this heat slowly damages the parts of the machines. And last but not the least, friction reduces the efficiency of the machines as some energy is always lost in overcoming the friction. Sometimes we increase friction and sometimes we decrease friction. This is increased friction, this is decreased friction. So we increase friction to make the things more useful to us. A very good example is the sole of the shoes. If you can see it closely over here, it has grooves to make it rough. I can also show you this as an example where there are grooves. It makes it rough to increase the friction to get a better grip on even smooth floors. Then you have tires of vehicles. I hope you can see it over here. They have treads. These treads increase the roughness and thereby the friction to provide a better grip with the road. Gymnasts, as you know, they apply a rough substance on their hands to increase friction for better grip while performing gymnastics. But mostly we reduce friction by applying oil or grease in machines where the surface is rubbed. The oil or grease forms a thin layer between rubbing surfaces so that they do not rub against each other. And by even sprinkling fine powder on something like a carom board, which makes the board smooth so that the striker slides easily on the board. I hope this episode of Friction was helpful. Thank you so much.